So today we are going to cover the first day of Section 5, Part A, and we're going to learn how to simplify rational expressions. Now, the first thing we need to talk about is domain. Now, right now in this lesson, we're not going to really focus on the domain and stating what the domain of the function is, but just know that whenever they ask you to state the domain, you're automatically going to assume that the domain is always all real numbers, except when there's a variable in the denominator, if there's a variable under a square root, or if there is a variable under a square root in the denominator. When these three things occur, that's when there's going to be some exceptions to the all real numbers. So I just wanted to show you what domain means. Later on, I'm going to ask you to state the domain and the range of a function. Let's just get right into simplifying fractions or simplifying rational expressions. So the first one, 6/30, looks like a 4th grade math problem. And all we're doing is simplifying that fraction. I can divide both the numerator and the denominator on 6/30 by 6, and this fraction will simplify to 1/5. Now, what we're going to be doing on the more complicated ones is they're going to expect us to factor it. Now, in 4th grade, they probably told you find the GCF and then divide the numerator and the denominator by the GCF. Well, the GCF of 6 and 30 is 6, and then that's how I divided both the numerator and the denominator by that GCF, and that's how I got 1/5. Now, what we're going to be doing on the polynomials is we're going to be factoring them. So we could have also factored the 6 2 times 3, and then also did the prime factors of 30, which were 2 times 3 times 5. And then I'll look for factors to simplify. 3 divided by 3 is 1. 2 divided by 2 is 1. And then you're just left with 1/5. Now, on a simple fraction like this, I'm not going to expect you to factor the numbers. I know that you're going to be able to simplify 6/30 and tell me it's 1/5. Now, for the next one, again, we're looking for some common factors to cancel. Notice the numerator has an x and the denominator, so x divided by x is 1. So then now I'm just left with 3 times 1 is 3, and 1 times y is y. So that fraction will simplify to 3/y. The next one, when we go to simplify rational expressions or fractions, the numerator, whatever's in the numerator, if it's a binomial or a trinomial, it would have to look identical. And in this case, x plus y over x plus y is the same. This will simplify. Now, it doesn't just totally disappear. I'm dividing. So x plus y divided by x plus y, anything divided by itself is 1. So technically what's left behind is a 1, and then 2 times 1 is 2. And 5 times 1 is 5. Same thing on the next one. The next one, even though the denominator is backwards, remember addition is commutative. So whether I write it as x plus y or y plus x, when I add two things, it doesn't change the answer. So these are actually the same thing. So what's left behind is a 1. And this one will also give me 2/5. Now, the bottom one, however, if you look at it, it is not identical. Notice the signs are opposite. However, what I can do to simplify this is factor out a GCF of -1. So out of the denominator, y minus x, and I could do this to the numerator as well, I'm going to factor out a GCF of -1. So I'm going to divide this one by -1 and this one. And then I'm left with -y plus x. And then if I flip it around, then it looks just like what I have in the numerator. So this would simplify to x minus y over -1 times x minus y. Now these simplify. This becomes a 1 and a 1. So now I have 1 on the top, -1 times 1 on the bottom, and then 1 divided by -1 is just -1. Be able to recognize when the numerator and the denominator look almost the same, but both variables have opposite signs. Oval here, or ellipse is what we're going to see later on. Notice there's nothing here that can be simplified. Let me show you a common mistake. Okay, and remember, this division bar or this fraction bar is like separating and making grouping symbols. So what this is it's 3 plus x divided by x times y. Now, in order to cancel 3 plus x, there would have needed to have been another 3 plus x. So common mistake here, our students are going to think, oh, I can cancel the x and the x. You cannot do that. This cannot be simplified. This is in simplest form, 3 plus x over x times y. Again, we're looking for a perfect match in order to simplify. The next one, notice this time the x is the same sign in the numerator as it is in the denominator, but y's are opposite. When this scenario happens and both variables are not opposite signs, I can't factor out a -1 to make it look the same. So nothing simplifies on this one, so this is already in simplest form. Same thing if I gave you something like this. Let's say I gave you 2 plus y over y. Remember, this is grouped together. In order to cancel 2 plus y, I would have needed another 2 plus y in the bottom. I can't just cancel these y's. If you do that on the test next week, you will get it wrong. It's grouped together. So this one is already simplified. So for the next one, nice, simple, easy fraction. It wants us to reduce the fraction 4 over 20. I can divide the numerator and the denominator by 4, and this will reduce to 1/5. Now, if I factored it, I could do 4 times 5 on the bottom. I could even go all the way to prime, but then simplify that. Again, remember what remains is a 1, so this is 1/5. You don't have to do this. I know that you all probably realize divide by 4, and it goes right to the 1/5. Now for number 2, on this one, it's being multiplied. So when it's being multiplied, I can cancel variables. But if this was x plus y over w plus y, I would not be able to cancel anything. So there's no plus or minus sign, so I can actually cancel the y's. So I can simplify, and these become 1's. And now I'm just left with x over w. Now, if it looked like x plus y over w plus y, this would already be simplified. When it's a plus or a minus sign in between them, I cannot cancel it because I would need to look for an identical match because it's grouped together. The next one, same thing. Notice this is grouped together, so I cannot simplify the x's here. This one is already in simplest form. Now, let's say instead it had x plus 1 over x times x plus 1. Now I've got a match. The x plus 1's will cancel. I'm left with a 1 left behind. And then this would simplify to 1 over x. So this is a totally new problem. This one could not be simplified. So you would just rewrite it. The next one is similar to the one that I just created. However, now in number 4, it's got the x times the x plus 1 in the numerator. Again, it's being multiplied here, x times x plus 1. So these x's will cancel. Only the one outside. What's left behind is a 1. So then here I get x plus 1 over 1. I don't need to write the 1 in the denominator. So it's just x plus 1. Now, before we move on, let me show you some similar scenarios of what to expect. So let's say we have x plus 1 over x plus 1. Remember, anything divided by itself equals 1. Because again, this could simplify. These become 1s. Now, same thing if it was a subtraction sign, x minus 1 over x minus 1. This is still going to simplify to 1 because anything divided by itself is 1. Now, if it had opposite signs, let's say it was x minus 1 and then x plus 1, this you couldn't do anything with. Again, do not try to simplify this and then tell me the final answer is -1. That would be wrong. This is grouped together. This is in simplest form. And then even if it's written backwards, 1 plus x over x plus 1. Remember, addition is commutative. So really, the top is really, you could flip it around, and this simplifies to a 1. Because it matches perfectly. Okay, so for number 5, still a nice, easy fraction, but notice up here in the instructions, hint, check to see if you can factor first. Now on number 6, we're going to factor that trinomial and factor a GCF before we start canceling. However, on number 5, I can simplify the fraction 3 over 6. This will simplify to 1/2. So I can change the 3 to a 1, the 6 to a 2. And then I can also simplify the x. This is like to the first. You could either subtract them or get rid of this one. And that becomes a 1. And then just get rid of the exponent. So the final answer here would be 1 over 2x. Now, if you'd rather factor it, you could do 3x over 2 times 3 times x, and then look for things to simplify. So the 3's cancel and simplify and become 1s. Then I can go back and cancel one of the x's, and that becomes a 1. And now I multiply what remains, which is 1 over, so 1 times 1 is 1, and then 2 times 1 times x gives me the 2x. Either way. Now for number 6, we have to factor that trinomial if it can be factored. So nice, easy trinomial. Factors of -12 that when you combine them give you +4. And that's going to be x plus 6 times x minus 2. The denominator, I'm going to factor out a greatest common factor of 3. And then I'm left with 3 times x minus 2. I now have a match, and I can cancel the x minus 2's. I'm left with 1's. Now, what I have left is x plus 6 over 3. Do not try to simplify the 6 and the 3. If you do, you just got it wrong. This is grouped together. So I took this and I divided 3x minus 6 by 3 and 3.
Oh, I didn't see that. Oh, okay. Never mind.
And then you get 3 times x minus 2. Do not try to simplify this. you will get it wrong. You are looking for an identical match in the denominator, and it would have needed to be an x plus 6. Okay, so again, the final answer is just x plus 6 over 3. Let's try the next one. Another nice and easy one. It's just a little simple fraction. Reduce 18 over 60. I can divide them both by 6. So I can change the 18 by dividing it by 6. What's left behind will be a 3. And then 60 divided by 6, and I'm left with a 10. And again, you can either subtract the exponents. You could do 2 minus 5, get x to the negative 3. So this tells me that the x will be in the denominator. So I have 3 over 10. And then because I got x to the negative 3, x to the third is in the denominator. Now again, if you prefer to factor it, the prime factors of 18 would be 2 times 3 times 3 times x times x. 60 would be 2 times 2 times 3 times 5 times x, 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 x. And then now you could look for things to simplify. The 2's are gone. Then you could do the 3. And then you could do an x. And then another x. And then if you multiply what's left over, you get... So then I'm left on the top with a 3, and then in the bottom, the 2, the 5, and the 3 x's. So 2 times 5 is 10, and then 3 x's is x to the third, and just the 3. So if you want to go through the whole process of factoring it and breaking it apart, you can, but you don't have to. However, for the trinomials and the binomials, we will need to factor those for sure. Let's try the next one, number 8. This time I need to factor both a numerator and the denominator. So for the numerator, I'm looking at factors of negative 20 that when I combine them will give me a positive 8. And those factors of negative 20 are going to be negative 2 and positive 10. So x plus 10, x minus 2. Doesn't matter the order you write them. Then for the denominator, factors of 10, that when I combine them give me 11, and that is going to be x plus 10 and x plus 1. Now I'm going to go back and look for things to simplify. I can simplify the x plus 10s, and what's left behind is a 1. Anything divided by itself is 1. And my final answer is x minus 2 over x plus 1. Again, do not cancel the x's here. I can't tell you how many times I see students do this, and then they tell me the final answer is negative 2. If you do that on the test, you will get it wrong. This is grouped together. You need to look for an identical match when it's being added and subtracted to look for things to cancel. Let's try another one. Number 9, I got a binomial and I got a trinomial. For the binomial in the numerator, it's not the difference of 2 squares, it's not a perfect cube, so I'm going to just look for a greatest common factor. And my greatest common factor is going to be 4. So once I divide out a 4 GCF, I'm left with x plus 3. For my denominator, I'm looking for factors of negative 18 that when I combine them, give me negative 3. Because the 18 is negative, that tells me my signs will be different, and it's going to be negative 6 times positive 3. And now, I'm going to look for things to cancel. The x plus 3's cancel, and then you're just left with a 1. And now I multiply what remains, 4 on the numerator and x minus 6 in the denominator. Again, do not try to simplify the 4 and the 6. That is already in simplest form. The next one, I am going to factor both the numerator and the denominator, both trinomials. Now, you can either choose to guess and test. for that denominator, or you could factor by grouping, either way. So let me go ahead and, now if you want to factor out a GCF of -1 out of the top and then factor what remains, or you can factor it as is. So if I factor it as is, it would become 4 minus x and 3 plus x. And then for the denominator, you can either guess and test, or I could also factor by grouping, which you'll multiply the beginning and the end. So I'm looking for factors of 8. That will give me -9. And those two factors are going to be -1 and -8. So 2x squared minus 1x minus 8x plus 4. Make your groups. GCF of blue is going to be x. So x minus 2x minus 1. And then over here, I'm left with, I'm going to divide out a GCF of the red group of -4, because remember, you want what's in the binomial to be the same. And then take what is the same, this, it's a GCF, and then put the two original GCFs you just divided by, becomes the second binomial. So that is the factor denominator. So I have x minus 4 times 2x minus 1. It doesn't matter the order you put them in here. Now, for now, to look for things to simplify, notice these two. Both the x and the 4 have opposite signs. So what I can do here is take this and I can factor out a GCF of -1. And then I'm left with -4 plus x. And then if you want to flip it around, then it matches. So this turns into -1 times x minus 4. Once you simplify it. And then now, things to cancel. The x minus 4s cancel. And you're left with a 1. But then we have the -1 times 3 plus x over 2x minus 1. So you can just write the final answer as a negative sign and then 3 plus x over 2x minus 1. You don't need to distribute it into the binomial. Now, let's go ahead and instead, I'm going to factor the numerator. This one's small enough where I could just guess and test. So for the numerator, I'm going to factor this into factors of 3 are going to be 3 times x. So I'll put a 3x here and an x here. And then my factors of -2 are going to be either +2 and -1 or -2 and +1. But it's actually going to be x plus 2 and then the -1 there. Again, FOIL it if you're going to guess and test. Now, for the denominator, let's go ahead and instead of factoring it the way that it is, let's rearrange it into standard form, just to show you can do this as well. And then factor out a -1. So then this becomes x squared plus 4x minus 5. So now when I factor it, I have the -1 out front, and then the factors of -5 that will give me +4 are going to be x plus 5 and x minus 1. And now I can look for things to simplify. And notice the x minus 1's cancel. And now you're just left with 3x plus 2 over, and I can just leave it as a negative sign, x plus 5. You could have also factored it backwards like I did on number 10. Or you can factor out the -1 to begin with and put it in standard form. All right, all we need to do here is pull out a GCF out of the numerator. So I'm going to pull out a GCF of, I'm going to pull out a -4 GCF, or let me do it first as +4. So I'm going to pull out a +4 GCF. So then what I'm left with is 3 minus x. And then the denominator, x minus 3. Now, if you pull out the positive, then you're going to still have to pull out a negative out of this. And then what remains here is a -1 and a 1. And then you would be left with -4 over 1, which is -4. Now, you could have also divided the numerator by a -4 to begin with. And then you would be left with -3 plus x. And then if you wanted to flip it around, -4 x minus 3, then it matches with what was in the bottom. And it goes right to -4. So either way, a lot of times you're not going to realize that you should have pulled out a negative GCF until you start to look for things to cancel. Next one. Okay, so for 13, notice the numerator is the difference of two perfect squares. So I'm going to factor it. It ends up being x minus 5 and x plus 5. And then I have my denominator, 5 minus x. Now notice the first binomial here looks like this, but opposite signs. So what I can do in my denominator is pull out the GCF, because remember I can divide 5 minus x by -1. And then it looks like -5 plus x. And then if I flip it around, it now is going to look like the top. So what I'm going to do is change this to a -1, this to a +1, and now multiply what remains. So now I end up with x plus 5 over -1. And then what I can do is either pull the negative sign to the top and leave it like that, or distribute it in. So on this one of these two answers would be acceptable. Do not leave the -1 in the denominator. You need to move it to the top and either distribute it in, or just leave the x plus 5 in a parentheses and put the negative sign out front. 14, I need to factor out a GCF. So for 14, I'm going to pull a greatest common factor out. Now, at first glance, you're going to think it probably needs to be positive, so I'm going to just do a +4. You could also do a -4 so it matches. But if I pull a +4x out, I'm left with 1 minus 2x. The denominator, my greatest common factor, is 5. And then I get 2x minus 1. Notice what's in the parentheses. The 1 is an opposite sign of the denominator, and so is the 2x. So again, I can simplify this, change this one to a -1, this one to a 1, and now multiply what's left. And I end up with -4x over 5. Now, if you would have pulled a -4x out as the GCF, then it would have matched perfectly, and you wouldn't have had to go back and divide by the -1. 15, I have a trinomial in both the numerator and the denominator. And again, you can either factor that numerator as is, or pull out the -1 GCF to begin with and rearrange it in standard form. So whichever you prefer. So like if you want to try to factor that x squared as positive, take the 4 plus 3x minus x squared, this numerator, and I'm going to factor out a GCF of -1. And then I'm going to also rearrange it and put it in standard form. So I'm going to put it as x squared minus 3x minus 4. Now I'm going to factor that trinomial. I'm looking for factors of -4 that will give me -3. So x minus 4 and x plus 1. Then I'm going to factor the denominator. And I can either choose to factor by grouping, or I can guess and test. Again, this is small enough where I could probably guess and test. So 2x, so the factors of 2x squared are going to be the 2x and the x. And then the factors of 4 are either going to be 1 and 4 or 2 and 2. Now to get a 7, I'm going to actually do a positive 1 and a negative 4. Now, if you're going to guess and test and not do the grouping, you need to FOIL this. So if I quick FOIL it, I get 2x squared, negative 8x, plus 1x, minus 4. When I group it, I did get that middle term I needed. So if you guess and test like this, then you really need to FOIL it, because if you put a negative 1 and a positive 4, you would get it wrong. So now I'm going to take the red that I factored here and put it on top. And then the x plus 1. And don't forget that you pulled out a negative 1 GCF, so put a negative sign there. And then now look for things to cancel. So the x minus 4's cancel. Nothing else cancels. So you're left with a negative sign, x plus 1 over 2x plus 1. And you're done. Do not try to cancel the 1's. Do not try to cancel any of the x's there. Again, I've got the difference of 2 squares in the numerator. And the denominator, I'm going to factor by grouping. So for the numerator, this is going to factor into x plus 1, x minus 1. And for the denominator, we're going to factor this thing by grouping. Let me just rewrite it down here. I'm going to make a red group and a blue group. My GCF of red is x squared. And I'm left with x plus 1. GCF of blue is going to be 9. And I'm left with x plus 1. And now I can put these two together, x squared plus 9, and then the two that are the same, the x plus 1. So that's my factored denominator now, x squared plus 9 and x plus 1. Now, if that x squared plus 9 was x squared minus 9, then I would have to keep factoring. But remember, there is no way to factor the sum of 2 squares, so that is fully factored. Now I'm going to look for things to simplify. The only thing I can simplify are the x plus 1's. And then now I'm left with x minus 1 over x squared plus 9. And I'm done. And again, do not try to cancel the x's, because again, remember x minus 1 is attached, as well as the x squared plus 9.